Dear students, today we are going to discuss a differentiation of a function. Now let f of x be a function and x equals to c be any point of its domain, means at this point this function is defined. Then derivative of f at x equals to c is simply denoted by f dash of c equals to limit x tends to c f of x minus f of c upon x minus c, provided this limit exists, that is limit x tends to c f of x minus f of c upon x minus c exists. Then we say that the value of this limit is the derivative of this f of x at x equals to c, and this is simply denoted by f dash of c. We denote this derivative also by df of x upon dx at x equals to c. Now you know that when you studied limits, limit exists means right limit equals to the left limit. Now here the left limit of this limit is limit h tends to 0, that is limit x tends to c negative is simply limit h tends to 0 f of c minus h, because by replacing this x by c minus h minus f of c upon minus h, and right limit of this is simply limit h tends to 0 f of c plus h minus f of c upon h. So here this is the right limit, this is the left limit, and this is the right limit. Now when the left limit exists, left limit equals to the right limit, then we say that this limit exists. When this limit exists, we say that this the value of this limit equals to the derivative of this point, derivative of this function at a given point. Here a left limit is simply called as the left derivative of f of x, that is here this left limit, it is called as the left derivative and is simply denoted by L f dash of c, means left derivative at point x equals to c. And this right limit of this limit is called as or f dash of c, means right derivative of this at f dash of c. When left limit equals to right limit, that is when for this left derivative equals to right derivative, we can say that then this f is differentiable or it is derivable at x equals to c, and we simply when this derivative exists, we simply say that this derivative is simply equals to limit h tends to 0 f of c plus h minus f of c upon h, because here this is left and right derivative. Now when this function is derivable, we say when this function, that is f, is derivable at x equals to c, then we can say that this limit exists. When this limit exists means its left and right limits are equal. When the left limits are equal, right and left limits are equal, so this means that value of these three limits is same. Hence we can simply, for simplicity, we can say that this f dash of c is simply limit h tends to 0, limit h tends to 0 f of c plus h minus f of c upon h. Now if we consider a function in a closed interval, that is f is a function in closed interval a b, then f is continuous on a b, that is over this domain, means that f is continuous at each and every interior point of this, that is whenever we remove these endpoints from this, means interior points, and left and right continuous at b and at a. Here this b here this b is the right endpoint. Now right endpoint, the points which are greater than b, this function is not defined. When the function is not defined, so this means that we cannot find the right limit at x equals to b, at x equals to b. So we can here simply find it is a left limit, that is we can find limit x tends to be negative f of x. Now when limit x tends to b negative exists and its value equals to the value of this function at b, then we say that it is a left continuous. Now similarly at point x equals to a, we cannot find its left limit, because the points which are less than a, because left limit means to find the approximate value, or to find the approximate value of the points which are less than a. Here at the points which are less than a, we cannot define the function, so this means that we cannot find its left limit, although we can find its right limit, because points greater than a, or the lies between a and b. So this means that here we are able to find its limit as well as the value of the function at a, so that is called as the right continuous. So right continuous is that function where right limit equals to the value of the function, and left continuous is that continuity where left limit equals to the value of the function. So this means that for the closed interval, this continuity, or the continuity over entire domain, means continuity, simple continuous continuity at each and every internal point, or the point which lies between a and b, and left and right this continuity at the end points. Now if we have the function as defined in this domain AB, then we say that f is derivable over entire domain if it is derivable at each and every point of its domain. Now but at endpoints, here at a and b, this function or any function, the function is never differentiable at these endpoints, because you studied in class 11th geometrical interpretation of this derivative at a point, and you know that derivative simply means at a point, simply means to find or to have the unique tangent at this point. Now if we consider the endpoints, if we consider endpoints, the graph of this function is like this. These are the endpoints. This is the a, and this is b. Now a and b, we have endpoint. This here we can draw infinitely many tangents at this point. So this means that when we are able to draw infinitely many points, this means that the slope is not unique. Slope means tangent of angle which it makes with the positive x-axis. So when tangents are not unique, this means that this limit is not unique. Hence we can say that at end points the function is never differentiable. Now we have to prove that every differentiable function is continuous at the given point where derivative exists. Now if f is differentiable at c, this means that f dash of x is simply f dash of c is simply limit x tends to c f of x minus f of c upon x minus c. Now we have to prove that this function is continuous, means limit x tends to c f of x is f of c. Now f of x minus f of c is simply x minus c upon x minus c f of x minus f of c, because by cancelling x minus c in the numerator and denominator, we simply get f of x minus f of c. Now taking limits as x tends to c, it is simply limit x tends to c f of x minus f of c. It is limit x tends to c, the limit of this. Now you know that the limit of product equals the product of limits, that is limit x tends to c x minus c into limit x tends to c f of x minus f of c upon x minus c. You know that this limit x tends to c x minus c, it is x minus c is here this polynomial. Its limit is simply obtained by putting x equals to c, that is this term is 0. Now this term exists because the given function is differentiable. Here it is differentiable because it is given that it is differentiable, so this value is finite. This value is finite means it exists. When it exists, so it is 0, and finite is always 0. So this means that this limit x tends to c f of x minus f of c is 0. When it is 0, so it is simply limit x tends to c f of x minus f of c simply out of this limit, because f of c is here constant, and you know that the limit of constant is always a given constant. So simply we can say that by transferring to this side, it is limit x tends to c f of x equals to f of c. So the limit exists and the value of the limit equals to the value of the function at given point. So this means that f is continuous at x equals to c. So differentiability at a point implies continuity at this point, but its converse is not true. That is, continuity does not imply, as in general, the differentiability at the given point. Now if we consider the function f of x equals to mod x, you know that it is continuous because the graph of this function at here it is 0 is like this. It is like this. Clearly it is continuous at x equals to x equals to 0. Now we will firstly find its left limit. Left limit or at 0 is simply denoted by L f dash of 0, which is limit h tends to 0 f of 0 minus h minus f of 0 upon minus h, which is simply limit h tends to 0 f of minus h minus f of 0 upon minus h. By putting it is simply limit h tends to 0 mod h upon minus h. Now mod h upon minus h is simply minus 1. And right f dash of 0 is limit h tends to 0 f of 0 plus h minus f of 0 upon h. That is limit h tends to 0 f of h minus f of 0 upon h, which is simply mod h upon h limit h tends to 0. Now mod h is h by h is simply 1. Here left derivative is minus 1, right derivative is 1. So this means that left derivative at 0 not equals to the right derivative. Hence by definition the derivative does not exist at this point x equals to 0, means this function modulus function is not differentiable at x equals to 0. So continuity at a point does not imply this differentiability at a given point. The reason for this is, now here if we consider a function whose graph is like this, that is v shaped, where there is vertex. Now at this point we can draw infinitely many tangents. Now when we draw infinitely many tangents, hence it is not differentiable. It is not differentiable. So simply we can say that if there is the peak or a vertex type, in any curve of a function, then this function is never differentiable at this point, because at vertex we can draw infinitely many tangents. Differentiability means if we are able to draw a unique tangent at a point or to a given point, then we can say that this function is differentiable. So thank you.